remember how to long divide just regular, like a 2-digit number into a 3-digit number or whatever. And as you recall, the first section the first part of this unit was adding, subtracting, and multiplying polynomials. We didn't talk about the last operation because it's a little bit more involved, but really follows the same process as what we did yesterday with just numbers. Now we're just throwing in variables in there. So the two methods to dividing polynomials are long division, which is like what we reviewed yesterday, so long division, and the other one is called synthetic division. Now, the reason we have two methods is because synthetic division only applies in certain cases. Like you can only do it if the thing that you're dividing into the other polynomial looks a certain way. And so synthetic division can only be used if the divisor is in the form x minus c. So that would be like, we would call that a linear binomial. So it has to be in that form, x minus c. It can't be 2x minus 3 or 1/4 x minus 1. It has to be something like x minus 2 or x plus 3 or something like that. Synthetic division is what we're going to start with on Tuesday. But long division really is not that bad, but we do have to know how to do both. Synthetic is a lot easier and quicker to do, but long division applies to dividing all polynomials, and since not every polynomial is going to fit this form, x minus c, then we have to be able to do both. So the examples for example 1, and I might actually switch to a different piece of paper here. Make an a and a b. We're going to do two examples together. The first one, okay, so for example 1a, the first one's going to be 2x squared plus 13x minus 7, and we're going to divide that by x plus 6. Now we're going to set this up just like we would any other long division problem. The thing that you're dividing into the bigger polynomial goes outside of the division bar. And then we put the other polynomial inside the division bar. Remember, this is called the divisor, this is called the dividend, and then the answer up here would be called the quotient. Okay, now I always go through a particular process. It's the same process that you go through when you think through dividing something like 24 into 2014. Like that. Same process, but because there's variables here, it's a little bit more involved. So I always start by putting my pencil in the first spot here, and I ask myself the question, what times x gives me 2x squared? Well, the answer to that would be 2x. So 2x times x gives me 2x squared. The 2x squared goes down there. But you can't forget about this 6. The 6 also has to be divided into it. So then now that you have your answer to the first one, 2x times x gives you 2x squared, you have to do 2x times 6 gives you 12x. And it should line up nicely there. And then we subtract, just like you would subtract if you were doing long division just with numbers. Okay, first term should always cancel out when you subtract. And then 13 minus 12 gives me 1x. The next step would be to bring down the next value in your polynomial, which in this case is -7. Then you do the whole process over again. So you go back up to the top, ask yourself the question, what times x gives you x? Well, that's 1. Okay, so 1 times x gives you x. And then you can't forget about the 6, so you got to go take care of it. 1 times 6 gives you 6. And then you subtract. When you subtract, the x's cancel out, and -7 minus 6 would end up giving you -13. Now, if there's nothing left over to bring down for your next step, then we would call this the remainder. Now, how you write your answer with polynomials is this would be your answer, 2x plus 1. But then this remainder is still being divided by x plus 6. So that would be how you would write your answer at the end. Okay, let's do another one together. B. let's do 4x cubed minus 3x plus 1. We're going to divide that by, I don't know, x plus, well, let's go x minus 2. Okay. For this one, we're going to set it up the same way. So x minus 2 goes into 4x cubed. Now, before I write the rest of it, one thing I have not mentioned yet, but is pretty important, is that if you are missing terms, so like in this case, we're missing our x squared, you need to put 0 as a placeholder. Alright, so what I mean by that is if you're missing like an x squared, then you put in 0x squared just as a placeholder. We might need it, we might not, but just in case we need it to line things up, we want to make sure it's there. And then minus 3x plus 1. Okay, and then you go through the same process. So you start your pencil at the very top, ask yourself the question, what times x gives me 4x cubed? Well, the answer to that would be 4x squared. And you can't forget about that negative 2, so 4x squared times negative 2 gives me negative 8x squared, and that's the reason why we have that placeholder, so that we can line up my like terms. Then you subtract. First terms would cancel out, and 0 minus a negative 8 would actually be positive 8. And then you bring down the next term. And then you go back up to the top. Ask yourself the question, what times x gives you 8x squared? The answer to that would be 8x. 8x times x gives you 8x squared. And you can't forget about that negative 2. So 8x times negative 2 is negative 16x. And then you subtract. First terms cancel. And negative 3 minus a negative 16 would actually be positive 13x. Because the two negatives would make a positive. Then you bring down the 1. Then you go back up to the top. What times x gives you 13x? Well, the answer to that is 13. 13 times x gives me 13x. And then you can't forget about that negative 2. So 13 times negative 2 gives me negative 26. And then you subtract. 13x's cancel. And 1 minus the negative 26 gives you 27. Because the two negatives make a positive. So your answer would be 4x squared plus 8x plus 13 plus your remainder, 27, and that's still being divided by your divisor, x minus 2. And that would be your final answer. Alright. I think we're going to do one more together just as review here. So, I don't know where you want to write it, if you want to write it on a different piece of paper or a page or something, but somewhere, make sure you write this down. First, one more time. Okay, so we're going to go with negative 3x cubed plus 2x squared minus 4x plus 9. We're going to divide that by x squared plus 1. Alright, so you set it up, x squared plus 1 is going to go into negative 3x cubed plus 2x squared minus 4x plus 9. I don't have any missing terms, so I don't have to put a placeholder. You're going to start the same way. So what times x squared gives me negative 3x cubed? Well, that would be negative 3x. Negative 3x times x squared gives me negative 3x cubed. And then I can't forget about the 1. So negative 3x times 1 gives me negative 3x. Now, if negative 3x times 1 is negative 3x, I'm not going to want to line it up underneath the x squared. I'm going to want to line it up under this negative 4x because negative 3x and negative 4x are like terms. So if that happens where the terms are spread out a little bit, that's okay. You can put a placeholder here of 0x squared, or you can just leave it. When you subtract these, they cancel out. 2x squared minus nothing is just still 2x squared. And negative 4x minus a negative 3 would give me negative x. Then we're going to bring down the 9. Yeah. All right. Then you go back up to the top. What times x squared gives me 2x squared? Well, that would be 2. So 2 times x squared gives me 2x squared. 2 times 1, because you can't forget about the 1. 2 times 1 is 2. So I'm going to line it up with a 9. Subtract again. First terms cancel. Negative x minus nothing, still negative x. And 9 minus 2 gives me 7. So this expression now, instead of just being a number, it's an expression. That's okay, though. That is my remainder because I can't answer the question, what times x squared gives me negative x? So your answer, when you write it, would be negative 3x plus 2, which is your quotient up there at the top, plus your remainder, which is still being divided by x squared plus 1. Okay, so just to give you a heads up about what we're doing next week, on Tuesday, you're going to be watching a video in class because I'll be at a PD on synthetic division, but it's really easy, goes really quick. Once you get the hang of it, it's fast, which is really good because we need to use it for stuff later on. And you're going to be reviewing long division, reviewing factoring, and keep working on the standards that we're covering. But that's how to divide polynomials using long division.